INEOS gel coats are well known for providing reliable, durable, real-world performance. To achieve this performance, it is important to properly apply the product. This video will outline all the key aspects of storing and applying INEOS gel coats in a manner that is safe and will provide lasting value to the end user. Safety. As you prepare to start your work, be sure to follow all safety procedures outlined by OSHA in your manufacturing facility. Before working with gel coat, review its safety data sheet. Take note of all safety precautions and use personal protective equipment recommended by the safety data sheet. PPE. To safely work with gel coat, a respirator, eye protection, gloves, and impervious clothing must be worn at all times. Gel coat storage. Proper storage is necessary to ensure the best performance of the gel coat. Gel coat should be stored between 75 and 85 degrees Fahrenheit. Do not store gel coat in direct sunlight, as it can cause the material to degrade faster due to excessive heat. Make sure all packaged materials are stored in their original containers with lids and caps tightly closed. Store resin and gel coat in separate areas for ease of inventory management. Follow first in, first out stock rotation. This will ensure you are always using fresh material. Before removing a drum of gel coat from the storage area, check the drum for damage. If you find a damaged drum, notify your supervisor. Catalyst storage. Catalyst should always be stored separately from gel coat and resin in a temperature-controlled environment. MEKP should be stored at or below 80 degrees Fahrenheit to maximize commercial warranty period. Catalyst should never be stored in direct sunlight. Follow first in, first out stock rotation. This will ensure you are always using fresh material. Contact your catalyst supplier for additional shelf life recommendations and proper storage techniques. Pre-spray documentation card. Check the certificate of analysis and package label to verify that you are using the correct material code, color, gel time, and batch number. Before beginning to spray gel coat, use an INEOS gel coat documentation card to record the gel coat material code and gel coat batch number. Proper documentation will ensure all of the important batch materials are captured, as well as outline the processing conditions. This information will be very useful to determine the cause of any defects. Use the same batch of gel coat for the entire part to achieve the best results. Mixing the gel coat. Mix the gel coat for 15 minutes before use. Use a paddle-type mixer in the gel coat's original container. The ideal mixer speed will change as the volume of the drum decreases. A drum which is full will require a higher mixer speed to create a bottom-to-top rotation movement in the drum. As the drum is used, the mixer speed needs to be reduced to prevent splashing or overmixing. Verify that the drum mixer is adequately turning the edges of the material in the drum. Allow the gel coat to recover for 15 minutes prior to spraying parts. Gel coat gun filtration system maintenance. The application of the gel coat will be altered if the gel coat gun is not properly maintained. Therefore, before spraying a part, check to make sure that the water traps have been drained. Use an air drying system to remove oil or water contamination. Oil and water can cause defects in the gel coat. The most common are dimples or fisheyes. Also, monitor the water trays on the spray gun. They should be drained daily. Verify that the traps have been drained before beginning to spray. Spray tip recommendations and maintenance. Selecting the proper spray tip is vital in gel coat application. The following recommendations will help you in selecting the proper spray tip. The size of the mold will determine the proper spray tip. Both the tip size and the pump pressure will affect the flow rate of the gel coat. Larger parts, such as large hulls, require a larger tip size to increase the flow rate. If you need to adjust the gel coat flow rate, make sure you are using the correct spray tip size. You should never increase the pump pressure to adjust the flow rate. This will over-atomize the gel coat, causing a lot of additional overspray. It can also lead to porosity in the gel coat film. Always use the lowest possible pressure to fully develop the fan spray pattern. Complex parts, such as decks, should be sprayed with smaller tip sizes, allowing you to control the film thickness of the gel coat. Thick gel coat on decks can lead to porosity and cracking issues. The spray tip size will be indicated on the spray tip. The first number listed on a spray tip indicates the fan pattern width. The next two numbers indicate the orifice size in thousandths of an inch. Lower numbers indicate a narrow fan pattern, and higher numbers indicate a wider fan pattern. Typical flow rates are as follows. The proper maintenance of the spray tip will increase the lifespan of the tip, as well as allow for the best application of the gel coat. Tips should be free from buildup and overspray. If a tip does become plugged, hard objects such as wires should not be used to clear the orifice. This can cause chips in the carbide portion of the tip and will cause the spray pattern to erode. It can also cause an inconsistency in the spray pattern commonly referred to as fingers. Tips will wear over time. The amount of gel coat sprayed and the maintenance history of the spray tip will determine how often they are replaced. Check the pattern and the flow rate from the spray tip. If the flow rate increases or the spray pattern declines, this indicates wear and the tip should be replaced. Catalyst calibration procedure. When calibrating the catalyst, you will want to first confirm that the spray gun is accurately dispensing the correct amount of catalyst. All spray equipment manufacturers have a special cap to put on the gun to check catalyst to gel coat ratio. The device will allow you to dispense catalyst and gel coat in separate streams to be collected in a suitable container. Place this cap on the gun and dispense material into the containers for 15 seconds. Weigh the gel coat and catalyst separately to determine the amount of material dispensed and use the following equation. Grams of catalyst divided by the grams of gel coat times 100 equals the percentage of catalyst. Next, visually confirm that the catalyst is being properly atomized. Typically, the catalyst atomizing air pressure should be set between 20 and 25 psi. Note that catalyst pressure can vary between 20 and 40 psi depending on the hose length. Use a catalyst percentage of 1.5% to 2.5% for best results. Catalyst levels below 1.5% and above 2.5% can cause poor cure and lead to a variety of gel coat issues, one of which is porosity. Recommended catalyst percentage will vary based on temperature and shop conditions. Contact your INEOS technical service representative for suggestions on the type and percentage of catalyst to use. As you continue calibrating the catalyst, adjust the fan pattern and pump pressure of the gun. You will want to spray the fan pattern on a vertical wall to verify pattern development. Using a vertical wall allows the catalyst to fall to the ground. If not properly atomized, pay special attention to any signs of catalyst fallout. It is crucial to verify that the catalyst is distributed correctly. If the catalyst pressure is too high, the raw catalyst can be blown through the spray pattern, which can cause porosity issues in large pits. If the catalyst pressure is too low, it will not allow the proper breakup of the catalyst and can lead to dimples and large porosity. It is poor practice to adjust catalyst outside of the recommended range in order to adjust gel time. This practice can compromise the gel coat's performance. Instead, use a material with an appropriate gel time for the climate, season, or size of the part you are making. Do not alter the catalyst level above or below the recommended 1.5% to 2.5% range without first contacting INEOS Tech Support. Temperature. Maintaining the proper temperature of the gel coat is essential. If the temperature of the gel coat is too low or too high, it will affect its viscosity and flow rate. Proper viscosity is key to successful gel coat application. Cold gel coat will have a higher viscosity, so it will be thicker and will cause underdevelopment of the fan pattern and porosity and leveling issues. Hot gel coat will have a lower viscosity and will be too thin. This can lead to sagging issues and poor tape line pulls. Temperature can be hard to control. The mold is a large heat sink. When gel coat is sprayed onto the mold, it will very quickly become the same temperature as the mold. In cold conditions, this will happen in a matter of seconds. This will cause the material to thicken and trap air. Check the temperature of the gel coat and the mold, as well as the ambient temperature. These temperatures should be between 70 and 90 degrees Fahrenheit. Pressure calibration procedure. Setting the ideal pattern is critical to optimum gel coat performance. Wider spray patterns will be required for large flat parts, such as hulls. More complex parts, such as decks, will require a narrower spray pattern. This should ideally be controlled by the proper tip size, not by the pump pressure. The ideal spray pattern is determined by the size and shape of the mold. Low pressures will prevent the gel coat from being broken up properly. This typically causes porosity issues. Set up a piece of paper or other disposable surface to develop your spray pattern. Set the gel coat gun pressure to 20 psi. Aim the spray gun at a piece of paper or other easily disposable surface. The tip of the gun should be anywhere from 12 to 18 inches away from the paper at a 90-degree angle. Pull the trigger to the spray gun and quickly release. Observe the spray pattern on the paper. Increase the pressure to 30 psi. Spray the gel coat onto the piece of paper and quickly release. Continue to increase the pump pressure in 5 psi increments until the spray pattern is fully developed. Adjust the air assist pressure to continue to develop the spray pattern. As the pump pressure increases, the spray pattern will become more developed. Your spray pattern should become more elliptical in shape as the spray pressure increases during the pressure calibration procedure. It is best practice to spray at the lowest possible pressure, which still yields a properly developed spray pattern. Too low of a pressure will prevent the gel coat from being broken up properly. This typically causes porosity issues. Too high of a pressure can cause more overspray. It can also cause the blowing of the gel coat to make it difficult to control the film thickness. This can lead to porosity as well. Record the final pump pressure on the gel coat documentation card. Basic gel coat spray techniques. Spraying a hull. Before you begin to spray, inspect the mold for damage and cleanliness. Make sure there is no polystyrene buildup or dust on the mold. Check the prepared mold for the appropriate mold release properties for the part configuration. Spraying the first pass of gel coat is the most critical. The goal is to completely cover the mold with gel coat, creating a coating thickness of 8 mils on the first pass. You should never exceed 12 mils wet on the first pass, or air can become trapped in the coating, causing porosity. Gel coat could be sprayed 18 to 36 inches away from the mold. You should never start or stop spraying on the mold. This should always be done off the part. Gel coat should be applied in 3 passes using parallel strokes that overlap approximately 20%, targeting 60 seconds between a pass using a cross-hatch technique. For large parts, spray smaller sections at a time to prevent air drying between passes. Use a mil gauge each time you complete a pass. You want to ensure that 6 to 10 mils have been applied with each pass. Use 3 or 4 passes to achieve an 18 to 20 mils wet film coating thickness. Record the mil thickness for each pass on the gel coat documentation card. Advanced gel coat spraying techniques. Spraying a deck. Spraying molds with corners and deep grooves can be a challenge. You need to be careful not to double gel coat thickness in corner areas. This will lead to the potential of porosity and cracking problems. To avoid thickness in the corners, spray down the corner in a single pass, then spray away from the corner area. For parts with deep channels, make sure the sides are sprayed in adequate thickness without spraying too much gel coat on the bottom of the channel. Test the spray thickness with a mil gauge frequently. To better manage the thickness, spray more slowly using 5 or 6 passes instead of 2 or 3. To properly apply gel coat in corners and deep grooves and channels, you may need to pre- or post-brush the gel coat. These areas should be brushed slowly in one direction. Brushing quickly or back and forth will cause air to be trapped in the film. After you've completed spraying the part, document anything unusual that happened during the process, such as a plugged tip or catalyst burst. This may help determine the cause if a defect is found. The part now needs to cure prior to lamination. Most gel coats require 1.5 to 2 hours of cure time for best results. Ensure there is adequate airflow across the mold so styrene vapors cannot lay in deep areas. Styrene vapor is heavier than air and will inhibit the cure. Always check the part prior to lamination to ensure that all areas are well cured and dry to the touch. This completes the INEOS gel coat application video. This video and its companion document outline best practices for spraying INEOS gel coat, which will result in better cosmetic parts. For additional questions and troubleshooting information, please contact INEOS Technical Service.